Previously, we have discussed dot product of vector. Now, cross product of vector and its application. Learning outcomes are students will be capable to explain cross product of vector and they apply cross product of vector in solving several problems related to vector product. Now, in vector product, the symbol of multiplication between vectors represented by cross symbol. The result of the product is a vector. For example, torque is defined as the product of force and moment of arm. Here, force, moment, arm, and torque all are vectors. Consider two vectors, vector A and vector B, making angle theta with each other. The cross product or vector product is given by vector A cross vector B is equal to mod A mod B sin theta n cap, where n cap is the unit vector along a direction which is perpendicular to the plane containing vector A and vector B. Also from this formula, we can find out angle, that is sin theta equal to mod of A cross B divided by mod A and mod of vector B. Now what is the meaning of A cross B? A cross B means the vector A is rotated towards vector B and its effect is taken on vector B. Direction of A cross B is given by right hand thumb rule or right handed screw rule. So, also see in this diagram, vector A cross vector B, the direction of A cross B is right handed screw rule, which is moving forward, means emerging out of the plane. And also in second figure, by right hand thumb rule, the if we fold the fingers pointing from A to B, then the direction of thumb will be the direction of A cross B. Now what is similar, we can explain the meaning of vector B cross vector A, means the vector B is rotated towards A and its effect is taken on vector A. In this case, the resultant is perpendicular and emerging out of the plane of the diagram. A best example to explain the meaning of cross product is closing and opening of a water tap. Now some properties of cross product. Vector product results in a vector. Vector product or cross product is not commutative. Remember, the dot product of two vector is commutative, but cross product of two vector is not commutative. That is, vector A cross vector B is not equal to vector B cross vector A. Another one, the cross product of a like unit vector is 0 because angle is 0 degree and we know sine 0 degree is equal to 0. Now I cap cross j cap equal to k, j cap cross k cap equal to I cap, k cap cross I cap equal to j cap. Similarly, j cap cross I cap equal to minus k cap, k cap cross j cap equal to minus I cap, and I cap cross j k cap is equal to minus j cap. Also, if we consider vector A equal to AXI cap, AYJ cap, and AZK cap, and vector B equal to BXI cap, BYJ cap, and BZ K cap, then A cross B. In the tabular form, IJK components of vector A, that is AX, AY and AZ, BX, VY, VZ. If we solve this determinant, we will find A cross B is equal to I cap into AYVZ minus AZBY minus AXBZ minus AZBX into J cap plus AXBY minus AYBX into K cap. Also, its modulus value, that is what will be the value of A cross B, so that is root under AY minus BZ minus AZBY whole square plus AXBZ minus AZBX whole square plus AXBY minus AYBX whole square. Now some applications of cross product of vectors. Within here we will discuss some application which is within our syllabus. First, torque, that is the rotational analog of force, and tau vector equal to R cross F vector. Area of a parallelogram, the magnitude of the cross product of two vectors equals the area of the parallelogram formed by those two vectors. In the diagram, we can see vector A and vector B, OA representing vector A, OB representing vector B. If we join AP and PB, we will get a parallelogram OAPB, and area of this parallelogram OAPB is equal to base into height, that is OB into AM. OB is magnitude of vector B and AM is A sin theta. So this we can write BA sin theta, and it is nothing but mod of vector A cross B. Another application, area of a triangle. The area of a triangle formed by vectors vector A and vector B is half the magnitude of their cross product. In the same diagram, we can see area of triangle OPB is equal to half base, that is OB into height PN, and PN is equal to AM. So this value will be half mod of A cross B. Next, volume of a parallelepiped. The scalar triple product, that is vector A dot vector B cross vector C, gives the volume of a parallelepiped formed by three vectors. Some more applications of cross product of vectors, like angular momentum. The angular momentum of a rotating particle is given by L vector equal to R cross P, where R is the position vector and P is the linear momentum. Next, magnetic force on a moving charge. The force F on a charge moving in a magnetic field B with velocity V is given by vector F equal to Q V cross B, and its direction will be perpendicular to the plane formed by V and B, and it will be taken by right hand thumb rule. Another one, angular velocity omega. In a rigid body rotation, V equal to omega cross R. Also, cross product can be used to checking for parallel vectors. If A cross B equal to 0, then vectors are parallel or anti-parallel. That is, angle between them is 0 degree or 180 degree. Thank you.